Aditya, are you there?
Yeah, can you hear me?
Yeah, I can. Okay. So today we'll have 1 hour class only because I think Shreya was not well today. Yeah, Shreya?
No, sir, I'm tired.
Okay, okay, no problem. So last class we were doing further application of integrals, and we had few more application left. So we'll take some questions. Okay. So other applications of Riemann sum. Other applications of Riemann sum. Okay. So now I will just take few examples which would require application of integrals. Okay. Let's start with this question. The density of cars, that is the number of cars per mile, okay, on 10 miles of highway approaching Disney World is given by the function f of x is equal to 200 times 4 minus ln 2x plus 3. So basically, they have given how many cars approach the Disney World, right? Where x is the distance in miles from the Disney World entrance. Where x is the distance from the Disney World entrance. Okay. Question is, find the total number of cars on this 10-mile stretch. Find the total cars on the 10-mile stretch from the Disney World entrance. Yeah. How should we do this problem?
So total number of cars will be density into distance, right?
Absolutely. So this is the density. So the car number of cars would be this, and you have to sum this up from 0 to 10.
Yeah. Okay.
Okay, that is what they are expecting you to do. So you just have to integrate this expression from 0 to 10.
That's the equation for the density, right? Yeah.
The function is giving you the density of car per mile.
Yeah. So you're doing it into the number of miles.
Yeah. So the number of cars in
got it.
dx mile. Number of cars in dx mile will be f of x into dx.
Yeah.
So density into f of x gives the number of cars, and summation is nothing but the process of adding up. So you are adding up all those cars and trying to find the answer. Now let's quickly do it. Let's quickly finish this up. So this is 800 minus 200 ln of 2x plus 3. Okay, and I have to integrate this from 0 to 10. So this is going to be 800x minus 200. What's the integral of ln of 2x plus 3?
2x plus 3 plus 1.
Yeah, just recall an integral of ln x. That's going to be x times ln x minus 1, correct?
Yeah. So 2x plus 3 into ln 2x plus 3 minus 1.
Absolutely. So 2x plus 3 times ln of 2x plus 3 minus 1. Okay, but whole thing divided by 2. Okay.
Yeah.
Remember the fact that you are applying reverse chain rule on this. Okay. So 0 to 10.
Wait, so why is it divided by 2?
Reverse chain rule.
Oh, okay.
Reverse chain
never
rule.
mind.
Instead of x, you have 2x plus 3, right? That's
Yeah,
it.
got it.
So that's going to be 800 means 8000 minus 100 times 2x plus 3. ln of 2x plus 3 minus 1. So can you just calculate this on your calculator, because ln and all we cannot find without using calculator. So that's going to be 23 times
ln 23 minus 1.
23 minus 1, and we have to put 0 also, right?
Yeah, that'll be
3 ln 3 minus 1. How much is it coming out? So
So log 23 you can calculate.
yeah, just calculate this out.
So don't we have to convert to log and then only we can get it first?
No, on your calculator you can use ln also.
Your mind is only log.
Which calculator you are using? You can't choose your base.
No. I mean,
Just explore it. Explore it. I think you can choose the base.
Wait, what's the difference between putting log and ln?
ln is to the base e, log is to the base 10.
ln is to the base e, log is to the base, lg is to the base of 10. Okay, anyways, I'll give you the answer. The answer they say is 3118.
So, but we use them interchangeably, right?
No. Base is something which is very important for log. Right?
Yeah.
Okay.
What happened?
Nothing.
Aditya
what?
is in a shock or what?
Who, me?
Yeah.
No.
We don't use it interchangeably. There's a difference between them. So
okay,
let me calculate here itself.
Wait, so how are we using like Riemann sum exactly here?
Exactly, that's what I'm asking.
Normal.
Riemann sum is basically what? Finding the area, right? So by multiplying with dx into f of x, probability car density into d of x, that's an area.
Okay.
See, I'll just let me do this calculation, then I'll show you how it works. 23 ln 23 minus 1 minus 3 ln 3 minus 1. Yeah, as you can see, the answer that they have given is 3117.94, correct?
Yeah.
So approximately 3118. Now see what is happening here. This is the car density graph. So basically, you're plotting car density. Car density means the number of cars per unit mile. Okay. So whatever is the graph, I'm not interested in plotting it. So if you try to integrate it from 0 to 10, the area in this gives you the total number of cars. Just like the area under the velocity curve gives you the displacement, the area between the car density and the x-axis will actually end up giving you the total number of cars. Okay, that's why it is using the Riemann sum. So basically, you are taking an elementary area.
Area under the curve.
Yeah, f of x is the height. This height is f of x, and thickness is d of x, and you're trying to sum this up.
Yeah.
Okay. Next question is, in 2000, the yearly world petroleum consumption was about 77 billion barrels. So in 2000 year, the petroleum consumption was 77 billion barrels. Okay. And the yearly exponential rate of increase in use is 2%. So this usage grows up by 2%. Okay. How many years after 2000 are the world's total estimated oil reserves of 1020 billion barrels going to last? How many years after 2000 is the world? This is the total reserve that I have. How many years after 2000 will this reserve likely to last?
This rate of change, right?
Such question really makes us feel worried about the consumption. This is called value-based question. Yeah, how do I do this?
It's rate of change, right?
But of course, you have to sum up also, right?
So the total sum is given to you as 1020.
No, that's the initial thing, but it decreases bit step by.
Oh,
How do I solve this question?
So just a sec.
See, first of all, let's say I'm using n barrels in a given year, so right? So dn by dt is given to us. That's 2%, correct?
yeah.
Okay. 2% of the current use, correct? So let's say at a given year you are using n barrels. So the next year the increment will be 2% of n, correct? Okay. So dn by dt is 0.0. You can say 0.02 n.
Yeah.
Correct. Now, if you see this, I can separate out n and I can separate out dt. Okay, let's integrate both sides. This will give me ln n. Okay, is equal to 0.02 t plus a c. Now, you are assuming that t equal to 0 is your year 2000.
Yeah.
So when t is 0, n is going to be 77 billion barrels. Let's say I'm talking about n in billion barrels. Okay. So n is going to be this. So if I
So
put
you
it over
see
here,
is LN77.
absolutely correct. So ln 77 is equal to 0 plus c. So c is ln 77. So yeah.
Wait, so n is the number of barrels consumed
Yes,
in a year.
In a year. So now, when I put it back, c value, that's ln 77. Okay, bring it to this side, it will become ln. Hope you know the log properties.
LN.
Okay.
Yes.
So n by 77 is e to the power 0.02 t. So n is going to be 77 times e to the power 0.0 t. Okay.
Okay.
Correct. Now, what I have to do here exactly? I have to exactly find out the number of barrels consumed every year. Correct?
Yeah.
So I have to integrate this expression. I have to add this expression. This is the number of barrels assumed every unit of time. What's happened to my list? Yeah. So 77 e to the power 0.02 t dt will be the total consumption that I would get. Okay. From 0 to n. 0 to whatever time capital D you can put. So this many number of barrels should match with 1020. So I have to find actually my T.
Yeah. Yeah.
Okay.
Yeah.
So when I integrate this, I get 77 e to the power
0.02
t.
Wait, so we got n as 77 e to the power 0.02 t, right?
Yeah.
So isn't N the number of barrels consumed in the year?
That is the number of barrels consumed after T
Yeah.
time. So it's basically like this. At T, the number of barrels
acha.
consumed is this.
Okay.
This height is 77 e to the power 0.0
Yeah.
t. So there is a
Okay.
function. There is a function like this. I mean, if I exactly draw this function, the function will be like this. Kind of this.
Okay,
Correct?
so the total area under the curve from 0 to the end will give you
Right. So
1020
this year is t to this year is t equal to 0, and that's 2000. So this
So you're
is
taking capital T as the last year, basically.
yes, absolutely. So I'm seeing that after how many years, that is capital T, will this entire reserve become 1020?
Yeah.
Okay. So this is 0 to T, and this is going to be 1020. So if you calculate this,
20.4.
I think 77 into 50 is how much? 3850, I guess. Okay.
You get 1 into 50.
Because 0.002 is into 50, no?
Oh, that
So
way, yeah.
this is going to be 1020. Okay, so keep your calculators ready. So e to the power 0.02 t minus 1 is 102 by 385. One plus 102 by 385. That's going to be 487 by 385. So 0.02 t is going to be ln of. So t is going to be 50 times ln of.
It's a hectic sound, bro.
Yeah, this is a good problem actually. So let me use my calculator. 387 by 487 by 385. ln 487 by 385. Okay, into 50. Into 50. 11.75 years. That means our time interval required is 11.75 years. That means in the year 2011, all the energy sources would have got depleted.
Yeah.
Okay.
So if they give the options as 11 or 12, we pick 11, right?
No, they will give you. They'll give
12
you.
it will not last.
Yeah, they will give you exact options. Don't worry.
Okay.
Okay. Next question. Okay. Question is a bacterial culture is growing at a rate of this bacteria in T hours. This much bacteria in T hours. Understood?
Mm.
That means the function, the bacteria, this is the density of bacteria. Correct? So if you want to see how much bacteria has happened in dt hours, you have to do 1000 e to the power 0.03 t into dt.
Yeah.
So this many bacteria would have come in that small time interval dt. Okay.
Mm.
Question is, the total increase in bacterial population during the second hour is approximately. Read the question. The total increase in the bacterial population during the second hour.
That means it will be from 0 to 2.
Increase in second hour. Second hour. What is second hour? After first hour is over, and second hour is over. This second hour is going on in between. Correct. Let's say 12 noon, 1 p.m. 1 p.m. to 2 p.m. This is your second hour running.
Yeah, so it's from 1 to 2.
It's from 1 to 2, yeah. So what is the increase in the second hour approximately? Okay. Options are 46, 956, 1046, 1061, 2046. 46. Done?
Wait.
So 1 second.
So basically you have to integrate this from 1 to 2.
Yeah.
So it's going to be 1000 e to the power 0.02 divided
By 0.03.
02 and it's from 1 to 2. So it will be 50,000 e to the power 0.04.
So it's 0.03, not 0.02.
Oh, sorry. Thanks for correcting me.
So the answer 16651.
See
No.
the options.
Oh my gosh.
So it's this by 3 e to the power 0.06 minus e to the power 0.03. How much is this, yeah?
There's a lot of calculation.
Yeah.
E to the power 0.06 minus e to the power 0.03 into
Just a sec. So I'll give you the answer. Wait.
So 1046.
1046 is absolutely correct.
Yeah, 1 second.
Is the question clear?
Yeah.
Is the approach clear? Correct. Okay.
Yeah.
Next question. Water is leaking from a tank. Water is leaking from a tank at the rate of leakage as a function of time, or you can say this is the rate at which the water is leaking from the tank. Okay, this many gallons per hour. Okay. The total amount of gallons that will leak out in the next 3 hours. So you can say this is the leakage with respect to time. So what will be dV? dV will be leakage into dt. So just remember this. So the question is the total amount in gallons that will leak out in the next 3 hours. Options are 1.00,
That means in the next 3 hours means 0 to 3
0,
integration.
in the next 3 hours is between
1 and 4.
leakage tank at a rate of this. Find the total
In
amount.
the next 3 hours, if you're taking it from 0, it will be 0 to 3.
No, it's the next 3. So 1 to 4.
Next 3, but you don't know I could also be at 2 and say next 3 hours, right? Why are you taking from 1 to 4 then?
Because you have to assume some value, then you can't
Wait.
find an answer.
Why will you assume some value?
I mean, you assume it starts from 0.
Exactly. It's pretty obvious. It will
Actually,
start.
they'll start from 0 only. Yeah, 0 to 3. Correct, Shreya.
So why are they saying next 3 hours?
I don't know. They should have said next year means, let's say time t is right now.
So what's the C option? 3 plus 3.
No, 3.13. Done?
Yes, sir. So is it E?
E.
Yeah.
Let's check options. 27. Question number E. Yeah, correct. So this will be minus 0.9. This will be minus 2.7 by 2 plus 6.
Plus 6. Around 3.7.
3.75. These many gallons you will lose in next 3 hours.
Yeah.
Okay. Next question is, the center of a city that we will assume is circular is on a straight highway. The center of a city that we will assume is circular is on a straight highway. The radius of the city is 3 miles. Okay, so there is some city which is circular and the center of the city is here, and this is on a straight highway. Okay.
The center is on a straight highway. Right?
Yeah, center is on a straight highway. Let's say like this. Okay. The radius of the city is 3 miles. The density of the population in thousands of people per square mile is given by FR, which is 12 minus 2R, at a distance of R mile from the highway. Okay. Again, I'm repeating the question. The density of population in thousands of people per square mile at a distance of R mile from the highway is given by this expression. What does it mean?
So I integrated from 0 to 3.
Okay, I'll not give you the hint because hint also contains the answer itself. Then the population of the city is given by
Density of
population is
people
given
into
by
number of into
0 to 3, 12 minus 2R dr, 2 times 0 to 3, 12 minus 2R integral of 9 minus R square dr, Option C, 4 times 0 to 3. 12 minus 2r under root 9 minus r square dr. Option D, 0 to 3. 2 pi r 12 minus 2r dr.
Mm.
Option E, 2 times 0 to 3. 2 pi r 12 minus 2r dr.
Sir, D.
D for dog.
D. Yeah, D for dog.
Okay. What do you think, Shreya?
Sir, I think E.
E.
Mm.
Why E?
Because if you're integrating from 0 to 3, you're only taking into consideration one half. You're not taking into consideration the other half. So it should be 2 times that.
I didn't understand you.
No, if okay, wait, just give me 2.
See, at a distance of r, if you go, okay, and you make a very thin strip like this of thickness dr.
Mm.
This is thickness of dr. So how many janta would be here? The number of
2 pi
people
r
would be here will be 12 minus
12
2r.
minus 2 into
Correct.
Yeah.
Into
Yeah.
the area of this strip, correct?
just 2 pi r.
That is 2 pi r dr, right? How much is the area of this strip?
Correct, 2 pi r D. It's 2 pi r D.
Is it circular strip or is it like vertical strip? Because they have not given anything about the nature of the strip. So can I assume it to be circular or should I assume it to be something like this?
So circular because it's a
Something like this. Let's say at a distance r, this is going to be a strip of dr, let's say. Then what should I do? It can be this also, right? So the number of people living in this area. I think this is the right approach. Circular will not work. This was not a correct diagram. Because the question says at a distance of r from the center, the population density is going to be this. Correct? So this has to be this area. Correct?
Yeah.
Now, what is this thickness? The thickness is going to be dr into the length of this, right? So this is r, sorry, that is 3. And this is r. So this length is going to be 9 minus r square under root, correct?
So, but R is what?
At a distance of r from the center,
So, can you make it something else? Because we know R is like 3. It's confusing.
no, r is not 3. R is a distance from the, okay, this is capital R then. Now it's fine.
Yeah.
Okay. Why I'm keeping it as small r is because the function itself is a function of small r, right? So I cannot change it.
Okay.
So this into dr will be the area of this, and into the population density is going to be the total number of people, and I have to integrate it from 0 to 3. Okay. But this has to be from both the sides, so you have to twice
yeah,
it
so
up.
it's 2 times.
Yes or no?
Which I didn't get. I didn't get it. So, wait, why are you making a triangle?
So a triangle. Please.
I'm not
Easy
making,
in Pythagoras theorem, finding out the length.
and this also will be twice
no.
up. So I'm not
Yeah,
making a
yeah.
triangle. See,
Yeah, okay, got it.
this will also be twice up because I just found out half the length. Correct.
Yeah, it will be 2 times that.
3 times more. So it will be 4
So
times
4.
this. So option C is correct.
He is correct.
Should I explain this again? See,
Wait, why is it 4 and not 2? I didn't get that.
okay, Aditya, just one second. Now I'll draw a proper diagram, see what is happening. Let's say this is the center of your city, right?
Yeah.
Okay. Now if I go r units away from the center, okay, and I choose a very thin strip of dr length,
Yeah.
okay, so this is the area that you are actually looking at, correct? If you multiply the population density with this area, you'll get the total number of people living in this area, correct?
Yeah.
Correct.
Yeah. Yeah. Yeah.
Now this area would be made up of dr into length of the strip, right?
Yeah. And length is given by 2 times 9 minus r square.
Yeah, so this is under root 9 minus r square, and this is also under root 9
Correct.
minus r square.
Yeah.
So area will be 2 times under root 9 minus r square into dr.
Into, yeah.
And if you multiply the population, this thing,
Yeah.
and let's say you integrate it from -3 to +3.
-3 to 3.
-3 to +3, that means 0 to 3 twice stuff. Then you'll get your answer, isn't it?
Yeah. Yeah. So it's how is 4 coming then?
Because the 2 from inside it took it out.
Okay. Yeah.
Okay.
Yeah.
Next question. A roast at 160 Fahrenheit is put into a refrigerator. There is a roast which is at 160 Fahrenheit. This is put into a refrigerator. Okay, fridge, whose temperature is 45 Fahrenheit. The temperature of the roast is cooling at time t at the rate of 9 e to the power minus 0.08 t degree Fahrenheit per minute. Degree Fahrenheit per minute. This is the rate at which the temperature is cooling in the refrigerator.
Yeah.
Find the temperature of the roast 20 minutes after it is put into the refrigerator. Find temperature 20 minutes after put in the refrigerator. Options are 45 degree, 70 degree, 90 degree, 81 degrees, 115 degrees.
So could you repeat the first part of the question?
Question is pretty simple. You have taken a roast and you are putting it into a refrigerator. And the refrigerator starts cooling the body at the rate of Fahrenheit per minute. They're asking you the temperature after 20 minutes of putting in the refrigerator.
So just integral of that from 0 to 20, and then you subtract that from 115.
115.
Like 160 minus 45 probably.
Try it out, try it out. So you're trying to find the decrement, correct? So in a small time dt, what would be the decrement? This would be the decrement, correct? So you have to integrate this from 0 to 20 and subtract it from 160. I'll not start the new chapter today because it will take some time. So we'll start it some other day.
Wait.
Tomorrow you guys are free, right?
Sir, I'm going out of station till Monday, like Saturday, Sunday, Monday.
Saturday, Sunday, Monday. Will you be able to watch the recording?
Yeah, but
Okay,
preferably
you
I
can
don't
do one thing.
I don't want.
See, you can do one thing. I will
Yeah.
I will put it on YouTube and share only the link with you. You can watch it live also.
As in,
I mean, instead of watching the recording, you can see the live recording.
in that case, I could also attend the class. No, but I won't have Wi-Fi, right? Like, I mean, like,
Yeah, understood.
yeah. So, like, preferably, I don't want to miss like too many classes. So, like, if you could schedule maybe like small, like 1 hour class or something. during
Yeah,
this
1
time.
hour class tomorrow. Because
So-
Sunday I will not be taking any class.
Okay, so you'll take on Saturday and Monday.
Saturday and Monday, yeah.
So 1 hour class. You will just do. So I got minus one. Sorry, no. I got the answer.
So is the answer C? Oh, sorry.
So it will become plus T this much.
Oh,
1 second.
So my answer is like 180 something.
so is mine actually, but I'm subtracting it.
It's like 160 plus like 20,
Yeah, plus 22.7.
22.7. Correct, exactly.
So you're getting more answer, right?
Yeah.
And then you subtract 45 from that. Do you do that?
Oh, 1 second. They have given minus 9 here. Oh, I'm sorry.
Okay.
Sorry.
So is the answer 9?
Then there will be a minus here as well.
So, but still it doesn't.
You get 137. So I'm saying.
So I think you
subtract
subtract
from
45 also.
115.
Yeah, exactly.
Subtract from
it's-
115. So
so
now
the
it's
answer is
C.
D, right?
How was it D? C.
81.
90. Around 92.
Okay, yeah, sure. Yeah.
Wait. So many speculations going on. So 0 to 20. But this itself would be a negative answer actually. Even though there's
Yes.
I don't know why you are getting this thing, but
Exactly. So the answer of that thing is 22.71.
Yeah. That's negative 22%, which gets added.
Yeah,
No.
that's what. So it becomes 160 plus 22.7,
Yeah.
which is nowhere.
Yeah.
yeah, this itself is a negative answer. So this has to be, this was correct actually, plus only.
So the answer will be. So I think you have to subtract 45 also from that.
Even then, it'll not make.
No,
even then, it'll still not be in the
why
options.
you are subtracting 45?
What?
Why you are subtracting 45?
So because the answer is nowhere near the thing then. I mean,
Okay.
it's, the answer will be 160 minus 22.71. Which is around.
Can I just take some more time to calculate this?
Yeah.
So 9 divided by 0.08. That's going to be 160 plus 112.5.
Hmm.
1 minus e to the power negative 0.16. That's going to be 0.147. So this will be a negative. Yeah. So into 112.5. Oh yeah, so it's going to be
22.71.
no, but there's no reason for us to subtract 45. Why would it be a reason for
So,
us
but
to
then your
subtract?
then
So then
answer.
answer will not be there in the question.
Wait. Then we have done some. Let me read the question once again. Question is.
So I think you do, because otherwise there'll be no relevance of that 45 degrees, right?
Yeah, and also they're saying that directly. What is it exactly? As you said, there's no relevance to the question.
No, there's no relevance of 45 actually in the question, because even if this 45 was not given, it not affect our answer. So it has to be. It doesn't make a relevance.
Then what's the answer, sir?
The answer
Okay.
is.
What's the answer?
One second. Let me just recalculate this. I think I have made some. Even you got the same answer?
Yeah. So what did you get it? 22.71, right? It's 160 minus 22.71, right? That's
Yeah,
what we,
what's it
Oh,
that's what we
that's
got.
1.6 over here. My mistake. This is 1.6. Now I should get the answer. I made a mistake here. Let me just correct it.
Wait, what?
Aditya,
Yeah.
we have not put the second limit.
Second limit
Because
is
it's
1.
9, but it's 0, right? We have to subtract that also.
But doesn't? Oh, it's e to the power. Oh, yeah. Yeah, it's e to the power.
Yeah, so the answer will be, just hold on for a second. So 160 plus 112.5 times e to the power of negative 1.6 minus 1. So they are giving me answer as 70.21 degrees. So that's B option is correct. Hello?
Yeah.
Yeah.
Wait, just. But how?
So this negative was to show decrease actually.
So you don't use it in the song.
But they've already mentioned decrease. That's why I subtracted over it. So they should say the rate of change like this, so that we always add it.
Okay, wait. So how does that come to 70.21? So that's the same as 160 plus 22.71
No,
minus
this quantity is
112.5.
negative. This quantity is a negative quantity. Check properly.
Yeah, I mean, say I multiply it, like say I open the bracket and multiply it. So it'll be 160 minus 22.71 plus 112.5, right?
Yeah. So
minus 112.5.
Yeah.
So how does that come to 70?
How much is 160 minus 112.5? That's approximately 47.5. And then you have to add 47.5
Oh, it's plus, right?
e to the power minus 1.6 into 112.
Yeah, I took it as.
That gives you 70.21. Okay. Next question is, a particle moves along a curve in such a way that its position vector and velocity vector are perpendicular at all times. I'll write it down. Position vector is perpendicular to the velocity vector at all times. Okay. If the particle passes through the point 4, 3, if the particle passes through the point 4, 3, then find the equation of the curve.
So do you have to use that physics thing which you said, that dot?
Yeah. So position, that's velocity. This is 0. Now dot product, how do you find it, Aditya? Just for you, you multiply this with this, you multiply this with this and add it. This is called the dot product.
Yeah, something like that.
Okay. This is 0 given to us. Now we have to find out the path of the particle, or the equation of the curve on which the particle is moving.
Just a second. Okay. Yeah.
Hmm. Hmm.
It's very obvious that it is just like saying x dx plus y dy is 0.
Yeah.
Correct?
Yeah.
Now integrate it both sides. So
Yeah.
x square by 2, y square by 2 is a constant. Correct?
Yeah.
Now, how do I get this constant? By using the fact that
You
the particle.
find the 4,3
Yeah.
substitute.
Yeah, absolutely. The particle is passing through 4, 3.
Mm-hmm.
So C is
12.5.
going to be 12.5. So x square by 2 plus y square by 2 is equal to 12.5. So x square plus y square
So y
is going to
square
be
is
25.
equal to 25.
So that the particle is moving on a circular path. That's why
Yeah.
at every instant the velocity is perpendicular to the position vector. This is called position vector. The vector connecting origin to the position is called the position vector. This will always be perpendicular. At any moment, if you see, this will always be perpendicular. Okay. Next question. Now, this question is a passage-based question. The velocity of a particle moving along a curve at time t is given by t comma t minus 1. Okay. The velocity of a particle moving on a curve at time t, where t is the time, is given by this expression. When t is 0, the particle is at 0, 1. Okay. Question number 1. Find the position vector of the particle at any time t. Okay. Second question is find the acceleration vector at t is equal to 2. Third question, the speed is at a minimum when t is equal to dash. The speed is minimum when t is equal to dash, filling the blanks.
So you just integrate for the first one, right?
No. Velocity is dx by dt, comma dy by dt. And you have to find this.
So
you have to
you integrate.
you have to relate first and then integrate.
Yeah, that's. I mean, yeah.
So this is t, correct?
So is the answer t square by 2 comma t square by 2 minus t minus 1 plus 1, sorry.
That is there in the options. Let's check. What do you get? But you have to put a c here. Now, how do I get c? By using the fact that when t is 0, x is also 0. So when t is 0, we have been given the particle is at 0, 1. So x is also 0. So 0 equal to 0 square by 2 plus c. So c is also 0. So your x will be definitely t square by 2.
Sir, is the second answer 1 comma 1?
That is also there in the options. Just let me get this over. Now dy by dt is given to us as t minus 1.
Yes, C is 1.
So dy is t minus 1 dt integrated. So y is going to be t square minus t plus again a c. Now here I have to use the fact that when t is 0, y is 1. So c is going to be 1.
So it's t square by 2.
Oh, I'm sorry. Okay. So that's going to be t square by 2 minus t plus 1.
Yes.
So that's going to be t square minus 2t plus 2 by 2.
Okay, you took it common.
Yeah. So this is the answer for the first part.
Yes.
Next is acceleration when t is 2. So acceleration is what? d2x by dt square, comma dy by d2y by dt square, and you have to find it as t equal to 2. Correct, Aditya?
Yeah.
So derivative of t itself is 1, and t minus 1 is also 1. So 1 comma 1 will be the acceleration.
Okay, that's it.
Now what is the time when speed is minimum? How will you find that out? Now what is speed?
Mod V.
Mod v. Mod v means t square t minus 1 whole square.
Yeah.
Now if this has to be
Sir,
minimum,
t is 0.
0 is there in the options,
No,
but 0 is not correct. Okay, so if this is minimum, that means even s square should be minimum. Correct?
Yeah. Yeah.
Now you can actually do double derivative of s square. Sorry, derivative of s square with respect to t and put it 0. That's 2t. 2 times t minus 1 should be 0. That means t plus t minus 1 should be 0. That means t should be equal to half. Now how would I check it's the minimum, not maximum? Double derivative. So double derivative of s square will be what? Double derivative of s square will be 4.
Yeah.
That's positive number. So s square is minimum, which implies s is minimum or speed is minimum at t equal to half. Are you getting confidence in these type of problems?
Yes.
So I've tried to touch upon various aspects of the application. Tomorrow when we meet, I'm going to start with differential equations, and you'll find that even these kind of problems are there in differential equation also.
So tomorrow you'll do a 1 hour class.
1 hour class. Yeah.
Okay, so you send me the link.
Yeah, I'll send you. Meanwhile, I'll send you the assignment also today.
Yeah. So can you send it like a downloadable link? Because like in case I get like some time to download it or something, then I can.
Downloadable will be a heavy file. Yeah, it will be a heavy file. You want the entire file to be sent to you, downloaded file?
No, so I can download it through YouTube. But the thing is, your video is a private link, so I can't download it. Like I can download on my mobile through YouTube.
But it will be very heavy. It will be in GBs.
Yeah, okay, that's true. So, yeah.
So,
I mean, I can try.
Okay, I'll see what I can do.
Yeah. Okay. Either way, just send me the.
Okay.
Link.
Okay. So what time is class tomorrow?
How about 6 to 7 or 7 to 8? I'll let you know. Do you have a morning, right?
4 to 6. No, I have 9 to 1, and then 4 to 6 I have a test. So
okay. So 6:30 to 7:30.
Cool. Okay.
So I have a question in this.
Yeah.
So why is ds square by dt 0?
See, I could have done ds by dt also as 0, but it doesn't make a difference because if your s is minimum, even this will be minimum, right?
Wait, so but isn't just s equal to 0? Like why is ds by dt 0?
No, they're asking when is s minimum? It needn't be 0. Minimum means least possible.
Okay.
The least possible of this may not be 0, right?
Oh, so it's like, okay, when derivative is equal to 0.
Yeah,
Okay.
so basically you have to use application of derivative over it.
Yeah, like minima based sort of.
Minima kind of thing. Yes.
Yeah.
Okay then.
Yeah.
Okay.